chemistry. Game. Cruzada. Since I know that.
Hello, can you
Hi,
hear me?
Nils. Can you hear me?
Yeah, I can hear you. How about you?
Yeah, I can hear you as well.
Okay. So, what topic are we doing today?
Last time I think we were doing balancing equations, I think.
Okay, you are clear with that, right?
Yeah, I'm pretty much clear with that, but I think it'll be good to do a revision or something.
So, shall we go ahead then?
Yeah, we can go ahead.
Okay. Which topic do you want me to take up then?
I would say balancing equations. Wait, I think I'll. Wait, I think you sent something.
Hmm.
Uh, yeah, you talked about balancing and atomic structure. That's the last lesson you did.
So, we were doing atomic structure in that case.
Yes,
You know
and
where
balancing.
exactly we reached there?
No, I think I forgot.
Okay. Do you
Are you
remember
are you
isotope?
sharing your screen or using a concept board?
Which one is better for you?
No, anything's fine.
Okay. Um, if you want a concept board, I can do that.
No,
Or if you're
no, it's
fine
fine. You
here,
can do you can do a PPT.
here you can annotate as well. If since it's Zoom, if it's Gmeet, you cannot.
I can annotate here. I think
We did atomic number and the mass number. Do you remember that?
atomic number and mass number. We did it a long time ago. I think.
Yeah. Ions,
So the atomic
isotope.
so the atomic number is usually on the top and the mass number is on the bottom, or is it the opposite?
The bigger number is the mass number. So some places they interchange that. Generally, the top number will
Yeah.
be the
I keep
mass
on
number.
forgetting. Can you just make an example?
Yeah. This one.
27 and 13. The one on the top is always the atomic number.
Mhm. This is the atomic number. That depends on the periodic table. How are they going to arrange? So you remember the bigger number is the mass number,
Yeah.
and the
So how would
smaller
it
one.
depend? So how does it depend among different groups?
In any group, it's the same. Bigger number is the mass number.
Yeah, but you told it varies.
I mean to say that in the periodic table, some periodic table might not have the mass number. They just have the atomic number. So it varies.
Yeah, sure. So it's always like this.
Yeah.
Yeah, okay. I think I remember that I wrote isotope somewhere.
These are the topics that we have finished so far, right? In the
Yeah.
structure of atom, we have finished atomic number. What about the electronic configuration?
Electronic. Oh, that depends on the type of group.
Yeah.
If it's in group one, it's going to be plus one. But if it's in group seven, it's also going to be minus one. If
No,
it's
I'm
group
not speaking
two,
about a charge. I'm speaking about the electronic configuration as in if you are given with an atomic number, say for example, the same element, aluminum 13, you would write 2, comma 8, comma 3.
yeah,
This you are aware, right?
yeah. Wait, where did two come from?
The first shell
Yeah,
will
yeah,
always,
yeah. Never mind, never mind. I know.
the next shell will have dot and the cross diagrams. Like how do you put the electrons as dots?
Electronic configuration. Should I write this down?
Hmm.
Okay, sure. So the mass number, it's divided into three different groups. It's divided into three different numbers.
Hmm. What? Sorry, I didn't get what the atomic number.
Yeah.
This atomic number can be written this way, where each of them represent a shell or the energy level.
Okay. What if it was written in 8, 2, and 3? Would it also be correct?
No, it's like the first shell is very small. It cannot accommodate many more electrons.
Yeah.
So it's
So
always 2,
then,
8,
so
3.
then how would you calculate that for 2, 8, and 3?
2 plus 8 plus 3 is equal to 13.
Yeah.
So that's the atomic number which is given to us.
Okay.
Is this clear?
Yeah, it's clear.
Okay. If I say Cl 1 minus 17.
So 1 minus is the electric charge and 17 is the atomic number, right?
Hmm.
That's correct, okay. So if you had 17, think you'd have 3, 7, and 7. Am I incorrect? Or
Hmm. Oh, can you come back? How do you write it?
3, 7, and 7.
Why is it 3?
Because 14 plus 3 is 17.
Always the first shell can maximum have 2 electrons. Once it's done, go to the next shell. It can have maximum 8 electrons. 2 plus 8 is 10. You need 7 more. So you put
Oh,
7.
it's always 2 plus 8 than
Yeah.
any number.
This is just for chlorine because there are 17. You see there is 1 minus charge. That means it has accepted 1 electron. You have to add that and it becomes 2, 8, 8.
Okay, wait, just 1 second. I'll
Ah.
just Google something.
Hmm.
Electronic configuration. Yeah, okay. Yeah, continue.
Okay. I'll go ahead with the next one. I'll say I have an example where I have Ca2 plus with 20. How do you write its electronic configuration?
So it's gonna be 2, 8, and 10.
The charge you have left, is it?
The charge. So is it gonna be 1, 4, and 5?
What?
1, 4, and 5. Does it depend on the charge?
No, if it is 2 plus, meaning what?
It its electric charge. It has two more electrons
Huh? 2 more electrons added or removed?
added.
No, removed. Plus 2 in the sense it's removed.
Two more removed. So it has 18 electrons.
Yeah, then how do you write 2?
So it's 2, 8, and 8.
Correct. That's clear.
Yeah, just wait. So metals lose an electron, non-metals gain an electron.
Huh?
Is it always E minus or E plus?
E minus.
Okay, then how is it? Then why was it E plus over there?
Where is E plus?
Ca2 plus.
The electrons are removed. After removing the electron, it gets 2 plus.
Yeah. So you're saying it loses 2 electrons and gains back 2 electrons?
No, 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 no. Basically, if you take calcium, this is the nucleus. The nucleus will have 20 protons. The first shell will have 2 electrons.
Yeah.
The second shell will have 8 electrons.
Yeah.
And the
And
third shell will have
8 electrons.
again 8 electrons. And the next shell will have 2 electrons. So it's like 2, 8, 8. Again, next shell can also fill 8, but we have just 20. So we write 2, 8 is 10. 10 plus 10 is 20. The first shell, if you take, it can maximum accommodate 2 electrons. The second shell can maximum accommodate 8 electrons. The third shell can maximum accommodate 8 electrons. The fourth shell can also maximum accommodate 8 electrons, but here we have 2 electrons.
Okay.
Basically, the third shell can have 18 electrons, but in your syllabus, like for the GCSE levels, you do not have to study that. When you go to the higher levels, you will study that it contains 18 electrons.
Yeah. Wait just 1 second. I'll write these down. Third shell can accommodate a maximum of 8 electrons.
Huh?
Okay.
8 electrons, you write, but actually it is 18.
18.
Huh.
Okay. Do I have to write the 18 next to it? Like you did?
Huh. Huh. No need to write. You can just do it.
Miss?
Yeah. Shall we go ahead?
Yeah, we can go ahead.
Okay. Now you see, totally there are 20 protons inside. That's 20 plus charges. And outside there are 20 minus charges. That's electron.
Yeah.
So overall the atom is neutral. So we write Ca.
Yeah.
Now let us assume that it has given 2 electrons. It has lost 2 electrons.
Because it's in group 2.
Huh?
Okay. So
Now there
which
are 20 protons still, and it has lost 2 electrons, so there are 18 electrons. So 20 plus 20 minus 18 is equal to plus 2. That is the charge we are going for, right? That means to say the electrons are lesser than protons.
Oh, so you're saying it's lost 2 protons then?
Ah, no,
Um,
last 2 electrons it is going to give.
yeah. Yeah, it gains 2 electrons, but then loses 2 protons.
No, no. Why will it gain protons? Protons are there inside. They will not get affected. It only loses whichever is outermost. This is easy to be lost. So it just gives off 2 electrons. Now you count. There are 2, 8, 8. There are totally 18 electrons. The protons are there inside. They will not get affected. So if you have plus 20 and minus 18, that gives you plus 2. That's the
So you just
charge.
calculate the difference.
Yeah.
Okay. Yeah, you can move on.
If I tell you some element, let's consider as X. Okay. It has 15 protons
Yeah.
and loses 3 electrons. Write the electronic configuration of it.
The
Second
electrical
one,
configuration of A.
draw the diagram, draw the
Okay,
uh,
sure.
shell diagram to represent it. and identify the charge on this.
Okay. So X has 15 protons. There are a maximum of 3 shells, right?
There can be any number of
So
electrons.
2 electrons. These ones are 2. Eight. Two plus. It's gonna be 2, 8, and 5.
Correct. So for X 2, 8, and 5, that's right.
X is equal to 2, 8, and 5.
What is atomic number?
Its atomic number then is going to be. Is it 15?
Hmm. That's fine. So you have written A. Draw the shell diagram.
Okay. How do I annotate? Oh no, I found the button. I found the button.
Okay.
Yeah, wait. 1 second. I'm using my mouse, so don't blame me.
Yeah.
One. There's one shell. 2, 3. There's 3 shells. So there's 2 of them in the first one. Wait. Then over here, there's going to be 8 in the next one. I'm not an artist. Then over here, there's 5 protons. No, 5 electrons.
Oh.
So there's gonna be 1, 2, 3, 4. I don't know where the 5th one goes. Here. So in the first shell, there's gonna be, wait. Yeah, so in the first shell, there's gonna be 2 protons. The next shell,
Not
there's gonna be 8
protons, it's electrons.
electrons. My tongue
Huh.
keeps on slipping. The first shell, there's going to be 2 electrons. The second shell, there's going to be 8 electrons. Then the next one, there's going to be 5 electrons. I do know that.
Okay. That's right. Now, identify the charge.
Okay. So I just need the periodic table.
No, I have given all the data required. From that, you can extract what is the charge on that.
Oh yeah, it has a charge of -3 then.
If it loses 2, 3 electrons.
It loses 3 electrons. Oh yeah, it has a charge of +3 then.
Yeah. 2.
So if it gains electrons, it has a charge. It has a negative charge. If it loses charge, it has a positive charge.
Yeah.
Ah.
Okay.
Oh, it's structured like that.
Oh. So it's the charge is x3 plus since it's losing. Is that clear?
Yeah.
Do you have any doubts?
No.
Okay, looking at this, you generally say that this is a general confirmation. It's not a hard and strict rule, but group 1 elements have. If I say the group 1, 2, 3, 4, 5, 6, 7, 8. If I speak about the charges, metals always donate +1, +2, +3. Later on, it decreases -3,
Yeah, I
-1, and
got this in my
-0.
book.
Yeah, you're clear, right, with this?
So the noble gases don't have any charge.
Yeah,
Okay. Yeah, you can.
exactly. So, why do you think the noble gases do not gain or lose electrons?
Because they don't react with other elements.
No, they do not react. No, it's the other way around. It's a opposite way. Like because they do not accept or gain, they do not react with anything. So what do you say? Why do they not react? Because they have eight outermost electrons, which is stable. Every element wants to have eight outermost electrons. These have gotten eight electrons, so these are considered as stable. So they are inert or unreactive.
So then what about group? Oh yeah, I think I get it. So for the non-metals, from groups 5 to 7,
Huh.
they all have a difference that they all have a difference from the group number and the charge number, right?
Yeah.
So is that how you calculate the outermost electrons?
Can you come back?
So is that how you calculate the outermost electrons?
Based on the group numbers, you calculate.
Or the
Group
group number is how many outermost electrons you have.
Yeah, exception is helium. Helium has got just two outermost electrons,
Yeah.
but it is in group 8. Okay. If I speak about the period number, whenever I write the configuration, let's consider as I have written 2, 8, 3.
Yeah.
1, 2, 3. There are three shells. So it belongs to third period. This is how you identify. So if
Okay.
you are given with any configuration, like any
Yeah,
A,
but then usually every element has usually three shells, right? So is every element going to be so every
no,
element
that
has
depends. How many separations you do, those many shells. The outermost electron you see, and that becomes the group number. This is how you do.
yeah, it's clear.
Okay. Next. Um, this is about the period, group, and all. Just give me a minute. I'm checking. Ions are done. Atoms are done. What is the electronic configuration for this?
For potassium.
See the charge and decide.
Okay. So for potassium and fluorine, okay. So you do know that it has an atomic number of 9.
Huh.
So, but then since we have three charges, and if you go for the maximum number of electrons possible, you're gonna get 2, 8, and 8, which has 20 electrons. So I think it's possible, I think. So it's gonna be 2, 8, and no, that's not it. 16. No, it's gonna be 18. So we have to add 4, so it's gonna have 4 shells. Capacity 16, 16 plus 2 is 18. So it's going to be 2, 8, 8, and 1. There's going to be 4 shells for potassium.
288 is that what you mean?
2, 8, 8, and 1.
No, potassium plus is given.
Oh, I forgot.
You have to check the charges also.
So for the plus, it just loses an electron. So it's going to be 18 outermost electrons.
Huh. So it's 2 comma 8 comma 8 comma 1 for potassium. Since it's potassium plus, it's 2 comma 8 comma 8.
Okay,
Yeah, go give the next one.
I'll do the next one. So this has an atomic number of 9, and since it has a negative number, a negative charge, it gains 1. So there's going to be 10 electrons.
Oh,
So it's going to be 2, 8, yeah, what? 2, 8, and 0? No.
oh,
It has a negative charge, right? That means it gains an electron.
huh.
Don't do it. If it has a negative charge, it gains an electron, right?
Yes, 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 yes.
So it's gonna have 10 electrons.
Huh.
Okay. But then if you put 2 and 8 all together, it's already gonna include 10. So is there no electrons in the outermost shell?
How?
If you do 2, 8, it's gonna already add up to 10.
Yeah, that means to say 9 was there. You have added. Its actual configuration was 2 comma 7.
So it
1
only
is
has
also,
two shells.
yes.
Adam. So they really do vary.
Yeah.
I was confused for a second.
Okay. But this is clear, right?
Yeah, now it's clear.
Any doubts?
Yeah, no doubt.
Shall we go ahead then?
Yeah.
Okay. This is all about the first topic, like atomic structure, structure of atom.
Atomic
Then,
structure and balancing equations, that's what I remember.
yeah, yeah, yeah. Then, if you go according to the topic, we have something called as separating mixtures. Can we do that? Separating mixtures.
Separating mixtures.
Uh,
Okay. Yeah, okay.
what are mixtures?
Okay, mixtures, I do know that they are a combination of elements that are not chemically bonded.
So they are physical
They are
combinations, right?
physically connected, but then chemically they're not.
Okay, physical combinations, right? Can you give me some examples?
Okay, water is a is a compound made by
Compound,
hydrogen and oxygen.
correct?
But then if you take a mixture of say, what if you take a mixture of say hydrogen, potassium, and chlorine all together and they're not chemically bonded? If you just put them all into a test tube, they're not gonna actually join.
Potassium is highly reactive that might react. So we can generally say air, where oxygen is there, nitrogen, carbon dioxide, all these are there, but they are not physical, chemically mixed.
Yeah.
Or you can say salt water. Salt just dissolves in water.
So it's NaCl.
Yeah, in saline water. Or you can say sand and water. Or you can say coffee.
Wait,
All
isn't
these are
salt water already chemically bonded? Because it has
no.
no, that's salt. NaCl and H2O. They can't join.
Yeah,
So salt, sand, water, coffee.
all these are mixtures. Shall we go ahead?
Yeah. So
If you have a mixture,
basically,
yeah, go ahead.
mixtures are elements that are mixed together but they're not chemically bonded.
Yes.
Okay.
Shall we go ahead?
Yeah, you can move
Okay. The next thing over here is, uh, yeah. Physical, chemical. How do you separate the mixture?
How do you separate mixtures? Filtration.
When do you apply filtration? What is the condition?
You
You
apply.
have a solid which is not dissolved
Where
in an
filtration is when there's a solid and liquid inside.
yeah, which is not dissolved.
Yeah.
So you take a funnel,
So
you place a filter paper inside, right? You pour the solution.
yeah.
Anything that is not soluble will settle here. I mean, which is not dissolved settles here. Rest all go. So whatever is there over here, this is called as residue. This is called as filtrate.
So the residue just rests on top of the filter paper and the filtrate just passes through.
Yeah. The combination of sand and water and the combination of any other particles like what else can you separate?
You can separate it through. I was gonna say chromatography, but then that's for identifying what if it's
Water
yeah,
and some uh, say
water and water and salt.
some metal parts like iron pieces if they are there in water. You
You
can
could
separate.
also boil water and then you'd have the remaining solids.
That's another technique.
Because if you take salt water, you just get it in a whole entire. If you get it in and you pour it, if you get a whole entire bottle of salt water, you pour it into like some sort of pot, and then you boil it. You'll have the remaining salts inside it.
Okay. The second method is called as evaporation.
Evaporation.
This is to separate the soluble salt from liquid.
Okay.
So the substance is already soluble in water. You take an evaporating basin, you pour the solution, you heat it strongly.
Yeah.
You will end up with the liquid. Liquid evaporates,
Yeah.
leaving behind solid.
Yeah. I'll
Is that
just
clear?
write. Yeah, I'll just write it down. It's
Ah.
clear. Soluble salts from liquids. Are there three ways, or these are the only two?
Sorry?
Are these the only two ways?
No, no, there are many. Once you're done, I'll go ahead.
But these are the main two that's gonna come up in the
No,
exam.
no, no, not this main. We do not say these are the
No, go
main.
back. Yeah, I'm just copying it down.
Okay.
Liquid evaporates. Wait 1 second.
Sure.
Ma'am, what'd you write over here?
Solution.
Solution. And this is heat, right?
Yes.
Okay. Yeah.
Crystallization.
Crystallization.
You follow part of evaporation, like if there is some impure solid, you have to convert it into pure solid. Okay. You pour this impure solid into hot water, or you can keep water and make it hot. Water, let's say hot water. You pour the solid, it gets dissolved, and then after that you heat it. Heat and vaporize subjected to evaporation. You remove almost all the water so that you get the saturated solution. Saturated in the sense very thick solution. Then
Yeah.
you allow it to cool.
Wait, what
When
was
it cools,
saturated solution again?
a very thick solution. I mean to say the salt concentration is very high.
So it has a very high salt concentration. Does it?
Yeah. Like when we cook, first there will be lot of amount of water. The water evaporates, and there will be a thick solution left, right? That's called a saturated.
Yeah. So you just wait for for the saturated solution to cool, then you'll just have the remaining crystals.
Yeah.
Okay.
This is called as crystallization. At the end, anything you get the pure crystals at the end. You evaporate, allow the saturated solution to cool, and then you get the thick crystals.
Yeah.
I am pasting an image of
Yeah, sure.
crystallized salt. How does it look like? Okay, this is just evaporation. You do not do the crystallization. You heat it strongly so that all water goes. Here, you remove 80% of the water and then allow it to crystallize. This is crystallization. Do you see the difference in the form of salt?
Yeah.
Yeah, right. The structure and all.
Hmm.
Is that clear?
Yeah, it's clear.
Okay. The next method is distillation.
Distillation.
Mhm. Okay. Just a minute.
No, what is that? Check my school bag. No. 1 second, miss.
Yeah, yeah.
Yeah, continue, miss. Yeah. Yeah.
Yeah, you can see the image that's pasted. Can you see this?
I think I've seen it. Do I copy this down?
Image, if you
Do
want
I
to,
have
you
to
can.
write it?
It's up to you. If you have to write,
Yeah,
if you feel to write, you can.
yeah, I think I'm good.
Okay, shall we go ahead then?
Yeah, we can go ahead. Just send me the notes afterwards.
Huh. Well, okay. So in the distillation, you have a soluble solid.
Soluble solid in a liquid.
Yeah. First, or a mixture of two liquids. Do you get that?
Yeah.
You are going to put it in a distillation flask. You can say this is the distillation flask. And you're going to heat it using a burner.
Yeah.
Then the one which has the lower boiling point. So this is based on the boiling point differences. The one with the lower boiling point will evaporate first. Once it evaporates, you can see that. So if there are two solutions, for the one with the lower boiling point will evaporate first, it will come here, it will pass through this chamber. You can see this, right?
Yeah.
Once it's evaporated, if it is in the gaseous state, then you circulate cold water through the condenser. You can see there is condenser over here, through which you can circulate the cold water. Then the gaseous state will turn to liquid,
Yeah.
and then you collect it. And the one with the higher boiling point is going to be retained in
Yeah.
the flask.
So the high boiling point will be in the flask.
Huh.
Yeah. You can continue now.
Okay. Water in say salt water, you can again follow the same method. Which is the earlier method that we discussed for salt water? Do you remember?
Filtration. No, no, no. No, the other one was evaporation.
Evaporation, yeah. Evaporation will evaporate all the water. You won't get water. Okay. Is this clear?
Yeah, it's clear. You can continue this.
Then what about how distillation and evaporation are different?
So evaporation are different because because you're only trying to evaporate the solid and not letting it cool down. But
Huh.
then but you actually do evaporation. Then once you have all the remaining solids
Huh.
that were not evaporated, you wait for them to cool down, and they'll be formed in a different way.
In distillation, you get water as well. In evaporation, you do not get that.
Yeah. You're
Is
talking
that
about evaporation and crystallization difference.
evaporation and distillation difference?
I thought you were talking about crystallization.
Huh. Distillation and evaporation.
Okay. So in distillation you get water, whereas in evaporation you have to let it go.
Yeah.
You don't get it.
Yeah. Uh, yeah. Fractional distillation.
Yeah.
Oh, do you know this? What it is?
No, I don't.
Okay.
Fractional distillation.
pasting another image. Just give me a minute. Okay, I'm pasting another image.
I don't see anything yet.
No, I have not pasted. I'm searching for a proper diagram.
Okay. No, you found it.
Yeah, this is a bit blurry, but you know what is it? Can you see any difference between this and this?
There are two chords. The
Sorry,
chords are used unlike in normal distillation.
which Kirk are you speaking about?
Chords are used in the fractional distillation.
Okay, you are going to use something here. This is the extra thing that is called as fractionating column that you do not use in the regular distillation.
Yeah.
Okay, it's a glass tube inside which there is bead-like structure. You need not know what exactly the structure is, but here, in case of distillation, you can just separate two things. Here, if you have multiple compounds, okay, separation of multiple mixtures you can do. As in, if I have a combination of 1, 2, 3, 4 liquids, you can separate depending on the boiling point. Here in the regular distillation, if you go back, if I have two substances, the boiling point difference must be more than 50 degrees Celsius, 40 or 50 degrees Celsius. If I have two liquids which have sufficient difference in the boiling point, I can apply this distillation. If they have close difference, I can't apply. But in case of fractional distillation, if the boiling point difference is smaller, we can apply this.
Yeah.
Like even 15 to 20 will also work.
So, so over here you separate multiple different mixtures
Huh,
in a single one.
huh.
What's the last one? Boiling point difference is smaller.
Boiling point difference is smaller in the sense the difference in the boiling point between the two substances should be smaller.
Yeah. Okay. Chal, you can move on.
Okay, moving ahead. Uh, now, water and ethanol can be separated from this.
Yeah.
The second thing is, uh, yeah, the next one would be, uh, yeah, the petroleum, the crude oil, they are separated using this.
So they use fractional distillation
Huh,
to get pure petroleum.
huh.
Okay. Yeah. Yeah, you can move on.
Okay. The next one would be the chromatography. What do you know about it?
Chromatography.
Yeah,
Isn't chromatography used to identify if a substance is pure or not?
correct. So you take a chromatography paper.
You're not actually filtering it then.
Yeah, you are taking a chromatography paper. Draw a pencil line here. Do not use a pen
You're
because
not supposed.
pen ink is also a mixture. It will interfere with the results.
Yeah.
Then you put it in a container where you have enough
We have
say
water.
solvent, and the solvent should be below
Above
pencil
the
line.
line. No, it should be below. The line has to be
Yeah,
above the solvent.
and you put the components that you want to check. Let's consider ABC, and after the experiment you are going to take it out
Yeah.
and check. Say let's consider this is the place where the solvent moved, and let's consider I have put ABC, right? A has moved here, B has created three spots, C didn't move at all. So I had ABC. This indicates you can see A makes only one spot, indicating it's a pure substance made up of one component. B makes three, so B is a mixture of three components.
It's an impure substance.
Yeah, and C that didn't move at all, so it's insoluble in the given solvent.
Yeah.
This is about the chromatography. Do you have any questions?
Oh, no questions.
This is about separation of mixtures.
Yeah.
Do you want to try some questions?
Yeah, sure. That'll be great.
Okay, it's loading.
A represents a mixture of compounds,
Hmm.
and B describes what a compound is,
Hmm.
and I think brass is a pure compound.
Wait a minute. Go ahead with which is the mixture here?
The mixture here is A.
They are
Or a
asking
mixture of compounds. I thought you were talking about a single mixture.
no.
Then it's going to be C, I think.
Why?
No, it's
It's not a
D.
mixture. It is made up of same substances. It should be B.
It should be of different compounds. Yeah. So what describes a compound is two or more elements physically combined, and I think
Oh,
brass is a pure compound.
huh. Brass is not a compound. Brass is a mixture. Or it's an alloy.
Or it's an alloy. An alloy means it's made up of two different metals, right?
Yeah, but it's not a physical combination. It's not a chemical combination. It's a physical combination.
Okay, then petroleum.
Huh. Petroleum. Pure compound they are asking, isn't it ethanol?
Pure.
Petroleum, I said it is a mixture. That's why we are separating it. Air is also a mixture.
Yeah. So ethanol is the only answer.
Yeah.
Okay.
Which one did you say for second one?
For second one, I told B.
It contains two or more elements chemically combined, right? It is not B, it is
No,
A.
B. Oh,
Compound.
no, compound. I thought you were talking about a mixture. Shit. Okay, so if it describes a compound, those are two or more elements chemically combined.
Yeah.
Okay. Matter exists as elements, compounds as mixtures. Which row identifies an element, a compound, and a mixture? So calcium is an element, chloride is a compound, brass is an alloy. Is an alloy also a mixture?
Yeah.
So then it's going to be C.
Element compound mixture. That's right.
Okay, complete the table which gives the names, symbols, and relative masses and relative charges of the three subatomic particles. So proton's symbol is N. No, it's P. Its
Huh.
relative mass is 1 and its relative charge is +1. Oh yeah, electron has a relative mass of -1.
0. Charge is -1.
Charge is -1 and for proton the charge is +1.
Huh.
Then this one's a neutron. It has a mass of 0.
Okay.
Atoms contain charged particles, but they are electrically neutral because they have no overall charge. Number 3 is correct. Then I don't
Oh,
know.
relative mass is not 0. Relative mass, they have mass, which is equal to the mass of proton.
So it's just 1. Okay.
Huh.
Atoms contain charged particles, but they are electrically neutral because they have no overall charge. One second. Yeah, it's true.
Atoms contain charged particles, electron, because they have no overall charge. You
This is
have to
correct.
explain it in the
It's
table.
correct since the nucleus has both protons and neutrons, and the electrons, and they have overall electrons. So there's
Equal
no
number of protons and electrons.
there's
Correct?
equal number of protons and electrons.
The
So
charges
if you
cancel.
so you can't classify which one contains more or which ones contains less.
Okay.
So therefore it has no overall charge.
Okay.
Atoms can form positive ions. Okay, how do you explain this?
They lose the electrons. So they become positively charged ions,
If they lose electrons, they become positively charged ions,
which we call as cations.
cations. Atoms of the same element can have different masses. True, because they might have a different number of outermost electrons.
No, 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 no. They are called as isotopes. The mass is not due to the.
But then an isotope is just one element that has a different that has a different number of outermost electrons, right?
No, 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 no. It has nothing to do with the electrons. So if I say carbon to carbon 612, carbon 613, you see in both the cases the number of protons and electrons are same. This is different. That means to say the number of neutrons is different.
Yeah.
So atoms of the same element can have different number of neutrons. That's why they are what do you say? Mass is different. It
Yeah.
has nothing to do with the electrons. Is that clear?
Yeah, clear.
Do you have any doubts?
No.
Shall we go ahead?
Yeah, we
Uh,
can.
I'll just wind up the class for today. Okay.
Mm.
I will send this PowerPoint to you
Yeah,
in the
sure.
group. Any doubts?
No.
Okay then. Yeah. Bye.
Yeah, bye.